At the end of this topic, you shall be able to explain the symbolic representation of a chemical equation, explain the reaction conditions involved in a chemical reaction, explain the states of matter or substances. What a chemical equation? A chemical equation is the symbolic representation of a chemical reaction. The reactant entities are on the left side and the product entities are on the right side. The reactant and product are separated by an arrow symbol. Each individual substances are separated by a plus sign. The arrow sign means react to form. The plus sign means and. The following points to be remembered while writing the chemical equation: nature of reactants and products, reaction conditions, and heat changes. The physical state of the substances should be indicated as a subscript in parentheses for both the reactants and the products. N2 plus 3H2 gives 2NH3. Use the following symbols to represent the physical state: solid, symbol S, example NaClS; liquid, symbol L, example H2OL; gas, symbol G, example O2G; solution in water, symbol AQ, example NH3AQ. Different arrows are used to represent the nature of the substance. The upward arrow is used to represent for the gas release, for example oxygen. The downward arrow is used to represent the precipitation formation, for example barium sulfate. Temperature, pressure, catalyst used or light should be indicated above or below the arrow. Some reactions involves heat changes which has to be mentioned in the chemical equation. On lowering the temperature makes more ammonia, and on raising the temperature makes less ammonia in this reaction. Some common Greek prefixes are mono 1, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10.
In this topic, you have learnt
a chemical equation is the symbolic representation of a chemical reaction. The reactant entities are on the left side. The product entities are on the right side. The reactant and the product are separated by the arrow symbol. Each individual substances are separated by a plus sign. The nature of the substance, arrows, and the reaction conditions are to be mentioned in the chemical condition. At the end of this topic, you will be able to explain chemical equation, state the law of conservation of mass, recall balance the chemical equation by hit and trial method, list the diatomic gases. The law of conservation of mass states that in a chemical reaction, the total mass of the reactants is always equal to the total mass of the products. Balance the equation by hit and trial method. The 3 steps to balance the chemical equation are: write the reactant and the product formula correctly on the respective sides. Example, the reaction between aluminium chloride and hydrogen gives hydrochloric acid and aluminium. The skeleton equation is: check for diatomic gas. List each element on each side of the arrow. There are 7 diatomic molecules. They are hydrogen, bromine, chlorine, iodine, fluorine, nitrogen, and oxygen. The chemical formula for 7 diatomic molecules are H2, Br2, Cl2, I2, F2, N2, and O2 respectively. Here chlorine is a diatomic gas, but it doesn't exist alone. Add coefficients to balance the equation. Balance the hydrogen atoms last and the chlorine atoms just before balancing the hydrogen atoms. Example 1. Reaction between sodium and chlorine. Solution. Step 1. Write the skeletal equation. Na plus Cl gives NaCl. Step 2. Check for diatomic gas. Cl is a diatomic gas. Na isn't a diatomic gas. Na is a metal. Na plus Cl2 gives NaCl. Check the number of elements in each side. Reactants Na1, Cl2. Products Na1, Cl1. The sodium atom is balanced. Chlorine atom is not balanced. Step 4. Multiply with the coefficients. Use hit and trial method. Chlorine has 2 atoms on the reactant side, but only 1 chlorine on the product side. Therefore, the atoms of chlorine on the product side must be multiplied by 2. Then sodium atom is unbalanced. 2 atoms of sodium on the product side and only 1 on the reactant side. In order to balance the sodium atom, the atoms of sodium on the reactant side is multiplied by 2. Reactants Na2, Cl2. Products Na2, Cl2. 2Na plus Cl2 gives 2NaCl. This equation is balanced. Example 2. Reaction between sodium carbonate and hydrochloric acid. Solution. Step 1. Write the skeleton equation. Na2CO3 plus HCl gives NaCl plus H2O plus CO2. Step 2. Check for diatomic gas. No diatomic gas. Cl2 and O2 are not alone. Hence, Na2CO3 plus HCl gives NaCl plus H2O plus CO2. Step 3. Check the number of elements in each side. Reactants Na2, C1, Cl1, O3, H1. Products Na1, C1, Cl, O3, H2. The carbon, chlorine and oxygen atoms are balanced. The sodium and hydrogen atoms are not balanced. Multiply with the coefficients. Use hit and trial method. There are 2 sodium atoms on the reactant side but only 1 sodium atom on the product side. Therefore, the atoms of sodium on the product side must be multiplied by 2. Now, the atoms of chlorine are unbalanced. There are 2 chlorine atoms on the product side and only 1 on the reactant side. Hence, chlorine atoms on the reactant side is multiplied by 2 and thereby the hydrogen atom also gets balanced automatically. Reactants Na2, C1, Cl2, O3, H2. Products Na2, C1, Cl2, O3, H2. Na2CO3 plus 2HCl gives 2NaCl plus H2O plus CO2. The equation is balanced. Example, reaction between aluminium hydroxide and sulfuric acid. Solution, step 1, write the skeleton equation. Equation, AlOH3 plus H2SO4 gives Al2SO43 plus H2O. Step 2, check for diatomic gas, no diatomic gas. O2 is not alone. Hence, AlOH3 plus H2SO4 gives Al2SO43 plus H2O. Step 3. Check the number of elements in each side. Reactants Al1, S1, O7, H5. Products Al2, S3, O13, H2. The sulfur atoms alone is balanced. The aluminium, oxygen and hydrogen atoms are not balanced. Step 4. Multiply with the coefficients. Use hit and trial method. There are 2 atoms of aluminium in the product side but only 1 atom on the reactant side. Therefore, the atoms of aluminium on the reactant side must be multiplied by 2. There are 3 atoms of sulfur on the product side but only 1 sulfur on the reactant side. Therefore, the atoms of sulfur on the reactant side must be multiplied by 3. Now balance the oxygen atoms followed by hydrogen atom at the last. Reactants Al2, S3, O18, H12. Products Al2, S3, O18, H12. 2AlOH3 plus 3H2SO4 gives Al2SO43 plus 6H2O. The equation is balanced. Activity 1. From the diagram, write for the reaction between A and B to give the product C. There are 8 A's and 2 B's reacting to form 4 C's with 2 A's unreacted. Therefore, the reaction between A and B is found to be 8A plus 2B gives 4C plus 2A. Divide the equation by its coefficient gives 4A plus B gives 2C plus A. Activity 2. Balance the following equations. N2 plus O2 gives NO. CaCO3 plus HCl gives CaCl2 plus H2O plus CO2. Na plus H2O gives NaOH plus H2. KClO3 gives KCl plus O2. N2 plus H2 gives NH3. NH3 plus O2 gives N2 plus H2O. N2 plus O2 gives NO. Step 1. Balance the nitrogen atom. There are 2 nitrogen atoms on the reactant side and 1 on the product side. Therefore, the atoms of nitrogen on the product side is multiplied by 2. Then we get N2 plus O2 gives 2NO. Step 2. Balance the oxygen atom. The oxygen atoms get balanced automatically. Therefore, the balanced equation is N2 plus O2 gives 2NO. CaCO3 plus HCl gives CaCl2 plus H2O plus CO2. Step 1. Balance the calcium element. You can see that it is already balanced by itself. Step 2. Balance the chlorine atom. There are 2 chlorine atoms on the product side and 1 chlorine atom on the reactant side. Therefore, the atoms of chlorine on the reactant side is multiplied by 2. Then we get CaCO3 plus 2HCl gives CaCl2 plus H2O plus CO2. Step 3. Balance the carbon atom. It is already balanced. Step 4. Balance the oxygen atom. It is already balanced. Step 5. Balance the hydrogen atom. It gets automatically balanced. Therefore, the balanced equation is CaCO3 plus 2HCl gives CaCl2 plus H2O plus CO2. Na plus H2O gives NaOH plus H2. Step 1. Balance the sodium atom. It is already balanced. Step 2. Balance the oxygen atom. It is already balanced. Step 3. Balance the hydrogen atom. There are 2 hydrogen atoms on the reactant side and 3 hydrogens on the product side. Therefore, the atoms of hydrogen on the reactant side is multiplied by the least multiple 2. Now it is seen different number of sodium atoms and oxygen atoms on the reactant and product side. Hence, to balance sodium atom on the reactant side and sodium hydroxide is multiplied by 2. Then we get, therefore, the balanced equation is 2Na plus 2H2O gives 2NaOH plus H2. KClO3 gives KCl plus O2. Step 1. Balance the potassium atom. It is already balanced. Step 2. Balance the chlorine atom. It is already balanced. Step 3. Balance the oxygen atom. There are 3 oxygen atoms and 2 oxygen atoms on the reactant and product side respectively. Therefore, the terms of oxygen atom on the product side is multiplied by 2. But even though then the oxygen atom is not balanced, now it is tried with a multiple 3 and on the reactant side by 2. Now oxygen atom is balanced. But potassium atom is not. It is balanced by multiplying by 2 on the product side with KCl. Then we get 2 KClO3 gives KCl plus 3O2. 2 KClO3 gives 2 KCl plus 3O2. Therefore, the balanced equation is 2 KClO3 gives 2 KCl plus 3O2. N2 plus H2 gives NH3. Step 1. Balance the nitrogen atom. There are 2 nitrogen atoms on the reactant side and 1 nitrogen atom on the product side. Therefore, the atoms of nitrogen on the product side is multiplied by 2. Then we get N2 plus H2 gives 2NH3. Step 2. Balance the hydrogen atom. There are 2 hydrogen atoms on the reactant side and 6 hydrogen atoms on the product side. Therefore, the atoms of hydrogen on the reactant side is multiplied by 3. Then we get N2 plus 3H2 gives 2NH3. Therefore, the balanced equation is N2 plus 3H2 gives 2NH3. NH3 plus O2 gives N2 plus H2O. Step 1. Balance the nitrogen atom. There are 2 nitrogen atoms on the product side and 1 nitrogen atom on the reactant side. Therefore, the atoms of nitrogen on the reactant side is multiplied by 2. Then we get 2NH3 plus O2 gives N2 plus H2O. Step 2. Balance the oxygen atom. There are 2 oxygen atoms on the reactant side and 1 oxygen atom on the product side. Therefore, the atoms of oxygen on the product side is multiplied by 2. Then we get 2NH3 plus O2 gives N2 plus 2H3O. Step 3. Balance the hydrogen atom. There are 4 hydrogen atoms on the product side and 6 hydrogen atoms on the reactant side. Therefore, the atoms of hydrogen on the product side is multiplied by 3 and thereby the oxygen atom is balanced. Then we get 4NH3 plus 3O2 gives 2N2 plus 6H2O. Therefore, the balanced equation is 4NH3 plus 3O2 gives 2N2 plus 6H2O. 2 molecules of sulfur dioxide react with diatomic gas of oxygen to form 2 molecules of sulfur trioxide. Diatomic gas of hydrogen react with diatomic gas of chlorine to form 2 molecules of hydrogen chloride. 2 molecules of diatomic gas of hydrogen react with diatomic gas of oxygen to form 2 molecules of water. Some chemical reactions occur naturally due to lightning. Examples: nitrogen in the atmosphere combines with oxygen to form nitrogen dioxide. Oxygen present in the atmosphere is converted to ozone. Nitrogen dioxide mixes with tiny droplets of water vapor to produce acid rain. It is harmful to plants. Write a balanced chemical equation for the following reaction. Materials required: ammonia solution, hydrochloric acid, conical flask. Procedure: pour a small volume of hydrochloric acid into the conical flask. Pour a small volume of ammonia solution into the same conical flask. What do you observe? The jar is filled with a cloud or smoke of ammonium hydroxide crystals. The reaction between ammonia and hydrochloric acid is NH3 plus HCl gives NH4Cl. Perform the experiment and write a balanced chemical equation for the reaction. Materials required: barium chloride solution, sodium sulfate solution and a boiling tube. Procedure: pour a small volume of barium sulfate solution into the boiling tube. Pour a small volume of sodium sulfate solution into the same boiling tube. What you observed? A white precipitate of barium sulfate is observed. The reaction between barium chloride and sodium sulfate is BaCl2 plus Na2SO4 gives BaSO4 plus 2NaCl. In this topic, you have learned an equation that has the same number of atoms of each kind on either side of the arrow is called a balanced equation. The law of conservation of mass states that in a chemical reaction, the total mass of the reactants is always equal to the total mass of the products. The 3 steps to balance the chemical equation are: Write the reactant and the product formulae correctly on their respective sides. Check for diatomic gas and list each element on each side of the arrow. Add coefficients to balance the equation. While balancing the chemical equation, balance the hydrogen atoms last and the oxygen atoms just before balancing the hydrogen atoms. There are 7 diatomic molecules. They are hydrogen, bromine, chlorine, iodine, fluorine, nitrogen, and oxygen. The chemical formula for 7 diatomic molecules are H2, Br2, Cl2, I2, F2, N2, and O2 respectively.